Welcome to Science, everybody. Let's talk metric system. A couple little basic things about it, and then how to do conversions, which is way, 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 way easier than the way we have to do it in the United States with the crazy units of measurement that we use. So, what is the metric system? Metric system. What's the deal? It was brought up and popularized during the French Revolution. So, what they aimed to do was get rid of all the old monarchies, aristocracy, all that kind of stuff. You should ask your history teachers more about this. I may be off, but create a system that was more based in logic and actual physical, measurable things here on the planet and things that connected with each other. Not things that are arbitrary, like the size of the king's foot, which changes, right? So all of the different units are really this may sound strange to write, but based in logic. And this was actually the root of it, that the distance from the pole to the equator would be what they defined as 10,000 kilometers, and then break it down from there to there to there to there. And here's one of the old, cool, original lengths of the meter in France. And they've changed the definition of it, but not really in essence. If you become a physicist that gets way into this, there's different ways to be super technical about how you define all these, but we're going to keep it simple here in our science. Why is this advantageous? Well, mass, volume, and length are all interconnected, so things make sense. And we use the same prefixes for all three. So all of our basic measurements, all three measurements. So all that we've got to do if we're going to convert is to learn to slide a decimal to the left or the right. Life is quite easy. Now, if you're trying to do that in the States to go from say inches to feet to yards to miles, you'd have to memorize a whole bunch of different numbers. Maybe some of them there's 12 inches in a foot. There's 3 feet in a yard. How about how many feet are in a mile? Do you know that? I do. Maybe I won't say it to just show you that this can be a frustrating system, right? I would have to say, if we didn't have this metric system, all of you go home and memorize all these numbers. I go home and memorize how many ounces are in a quart and quarts in a gallon and all of that. And then go to mass and think about how many ounces that are different than those other ounces there are in a pound and a ton and blah, 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 right? It's a lot of memorization, whereas here, no memorization. Just slide a decimal back and forth for the different prefixes, and you're done, right? So if we start with the base unit, which is going to be the thing that's in the middle of this diagram, both on this and on the lab you're going to do, what we do for a base unit of mass is grams. Volume is liters. Meters. Again, they all interconnect. So if this was the original idea, this 10,000 kilometer thing, and we got it down to meters and we got it down to centimeters, centi, like cents, how many cents does it take to get a dollar, or centipede or century? All are hundreds, right? So cent, there's 100 of them. This is a meter stick, if I can get it all on the camera. And it's got 100 centimeters, just like a dollar has 100 cents and a century is 100 years. Or milli, like millennium, millipede, maybe. I don't think they have thousands of legs, but that's kind of the idea. There'd be 1,000 of them. So there's 1,000 of those in this meter stick, 1,000 millimeters. Now, where else did they say, hey, let's make some sense out of this? They said, let's take what this centimeter is. If you make a box that's that big, 1 by 1 by 1, a little tiny cube, let's say that's what a milliliter is. So that's 1,000th of a liter. And now these two are linked up. And if we want to throw in grams, well, let's take a very common substance like water and say that what is the mass of 1 milliliter of water? That's what we're going to call a gram. So they all kind of work together. And then you can even get into temperature, and it takes 1 calorie to heat 1 gram by 1 degree Celsius. And then the Celsius scale goes from 0 to 100. Everything kind of makes sense once you learn it. It's a lot easier. Versus, do you know the standard numbers for temperature? Freezing is 32 and boiling is 212. Again, more memorization of arbitrary numbers. 0 to 100. Life is simple. All right, so let's do some. There's a whole bunch of practice ones over here. Don't panic. I'm not going to have you do all of them. I'll have you pick a handful of them. Because once you get it down, you're good. All right. So determine your starting points, count the jumps you need, and then move the decimal the same number of spaces. So I figured let's do some measuring. I have a board game here. Surprise, surprise. Let's measure how tall it is. I have it at 6.2 centimeters. All right, I'm going to write that down over here. Do the same. Join me. If that's, where do we get some space? 6.2 centimeters tall. If I wanted to know how many meters tall that is, what do? So all you're going to do is say that decimal is the important spot. You go to whatever box you're at for that decimal. So if you're in the centi box, here we are. We're in centimeters. And if I want to say how many meters tall, keeping in mind this is a meter, so that board game is not going to be very many meters tall. Let's see how many. Count how many you got to get to that basic unit of meters, which lives here in this basic unit box. So I'll switch colors just for the heck of it. 1, 2. I had to go 2 spaces to the left. So I do the same thing with my number. I grab this decimal right here. I go 1, 2 spaces to the left. That's the new spot that my decimal lives. And since there's that little thingy there for where I skipped, you chuck a 0 in there. So this board game is 0.062 meters tall. What if I wanted that in centimeters? No, I have it in centimeters. Sorry. What if I wanted that in millimeters? All right, it's 6.2 centimeters tall. How many millimeters tall is that? Well, we go from centi to milli. You go 1 space to the right. So I grab that decimal. I go 1 space to the right. And this board game is 62 millimeters tall. It's all the same measurement, of course. This box isn't changing sizes, but we're just putting it in those different units. And again, it's just as easy as sliding a decimal, not having to worry about memorizing how many of these things are in these things. All right, so the example they have here in this little diagram that I stole from the internet, 4 kilometers to meters. If we had to say how many meters is 4 kilometers, in other words, the stick, how many of these sticks fit in a 4 kilometer race or whatever, you'd have to go 1, 2, 3. That's what they did for you up there at the top. So you grab the decimal. It does take this does take knowing that if you write down the number 4, no, I don't see a decimal there. Yes, there really is a decimal there. We just don't write it when we don't need to. 4 is the same as 4 point or 4.0, whatever. So if I go just like they did right here, 1, 2, 3 spots to the right, fill those with zeros, I get 4,000. So that it would take 4,000 of these sticks to do a 4 kilometer race. Okay. Now, what other ideas are kind of hiding in here? I guess we should. We've already mentioned this. Let's do this. It's much easier than the standard system. We would need to know, if we weren't using the metric system, each conversion factor. Memorize them all. For example, there are 12 inches in a foot. There are 3 feet in a yard. And if you haven't looked it up yet, there are 5,280 feet in a mile. And then totally different systems for mass, unrelated, no numbers relate to each other. And again, start all over with all new numbers to memorize. Volume. Silly. So what countries do not use a metric system? I'm not going to put it on here because it's in your lab. You're going to try to figure it out. So again, the only other like mini thing that might be hiding in here, and I didn't put it in these notes, but it is in the lab, is how do we know like what units to use? Well, it should be appropriate to what you're trying to measure, right? Centimeters and millimeter, I think, are a good measurement for how tall battle sheep is here, right? But meters, it was kind of silly. 0.062, like that's not. I don't know. It's not like as useful for me, and it would be preposterous to try to report it in kilometers. I mean, we could do it. It would be 1, 2, 3, 4, 5. So it would be 0.0000062, right? Which is kind of silly. So what are you trying to do? Are you trying to measure the height of this box? Or are you trying to measure the distance from here to Oswego arbitrarily, right? You probably wouldn't want to measure from the school to SUNY Oswego in millimeters. You'd want to use something bigger, like kilometers. All right, so picking the appropriate one It was good. All right, so as you're doing this, I'm going to try to watch, and I'd like to do like one little mini hot seat quiz where I say, okay, whatever your name is, Steve-O. Right now you're on number 6B. Do it for me, and I'm going to say you're good. So practice some of these, and if once you do a couple, say, hey, Mr. F, I think I got this, and I'll pick one more for you. Do 5-ish, 10-ish. Let's do one together. 2,000 meters is how many kilometers? I put it here again sideways, which was kind of handier when we were doing it on paper, but on the computer here, do whatever works for you. So 2,000 meters with a decimal right there. How do I go from meter to kilometer? I go from my basic unit of meter, and I go 1, 2, 3 to the left, which means I'm grabbing this decimal that, again, we know is right here. Let me make this bigger. We know that this decimal is right here, 2,000 points. And if I go 1, 2, 3 to the left, now it lives right there. So that's 2.0 kilometers. How about we go backwards? Yeah, let's just do a totally different one. Milliliters to liters. That's kind of the same. Liters and milliliters. I like this one. 6 liters is how many milliliters? So liters is in the middle. That's our basic unit. I'm going to go 1, 2, 3 to the right to get down to milli. So I know that there's a decimal there. 1, 2, 3, 6,000 milliliters. Now, again, some people are going to just be able to, like, if you figure these out and you got a good head for it, and you know the centis are 100 and so on, you might be able to do that pretty quickly. But if not, that chart is there. Once we switch to the lab, that's there. I wouldn't anticipate that you have to do that ever without this chart thing. You wouldn't be like on a test or a quiz. You wouldn't have to do this without the chart. That's always there for you. Some people have like a little KHD DCM sentence. My math teacher, for whatever reason, Kelly helps dad make dog collars Monday. That was in middle school and it stuck. King Henry died drinking chocolate milk, I know, is a popular one. Again, those are silly, but maybe they help. But again, I wouldn't sweat necessarily trying to memorize that thing. It's more just be able to use it. So try a couple of these. When you think you got it, say, hey, Mr. F, I'm going to try one. I'll either come over or I'll watch you do it here, and we'll say that you are good. You can skip the rest and move on to the lab. Thanks, folks. Keep up the good work. Next is the metric measurement lab. As soon as we get a stop button here. There we go. Good luck.